Okay, so today is a review of all the ways we could factor some quadratics. And the way we solve a quadratic is by factoring. So we're going to refresh our memories. So the first thing we could use to factor is by using the GCF. So I like to say GCF, write what's left. So let's do number one together. Number one, the greatest common factor out of both of these is 6. So your GCF is 6. So if I divide this by 6 and this by 6, you know what's left? 2k minus 3. So the GCF is 6. And then you write what's left. So 2k minus 3. So something like that's very simple. There's so many problems. I'm going to just do the odds, I think, today. Number 3, I'm looking, what's our greatest common factor? Is definitely a 7 and an m. So I'm going to put 7m on the outside. Ooh, actually an m squared, because I could take 2 of them out. All right, so I could take 2 of them out, so that would leave me with a 2m to the 4th, because remember, you just subtract the exponents. 7 divided by 35, so that would be 5. If I take 2 away, that would leave me with just an m, and then that would leave me with just negative 1. Then this is like the method we learned back in Algebra 1. When factoring, always look for a GCF first. The way I learned it, I know there's multiple ways to doing this, but I learned one way, and you'll see hopefully it's the same way. I always like to look at the n number, and I write down all the things that multiply out that I know. And like 45, I know 3, 15, and I know 9 and 5. Right? Those are the ones. So whatever multiplies to this and then adds to this. So 3 plus 15 does not add to 14, but 9 plus 5 does. So it's x plus 9, x plus 5. So I hope everyone kind of remembers that method. Let's do some more. Now I have a negative. So I have 48. So I automatically think of 6 and 8. I think of 4 and 12. I know 2 and 24. Those are some, and I need it to add to positive 2. Looking at these, if I make this a negative 6 and this a positive 8, I would add up to a positive 2. So I'm going to write it as x minus 6, x plus 8, and that would work. 36, there's so many things that go into 36. We have 2 and, oh my god, why can't I think? 36 divided by 2. It's 18, yep, 2 and 18. I could do 3 and 12. I could do 4 and 9, 5, 6 and 6. All right, so these are all our possibilities, and we need them to add up to 12, which right here, I see the 6 and 6. Oh, it's an A. A plus 6, A plus 6, and we could even write that as A plus 6 squared, just because it's both the same. For number 11, I could divide all of these by 2, because notice there's a 2 in front. All these other ones, there's nothing in front of A. I'm just going to divide everything by 2, and I'm just going to put that in the front. So I have 2, so it would be k squared minus 8k minus 20. So now let's see if we could factor the 20. I know 5 and 4, 2 and 10. So it's a negative 20. So one of them has to be negative, and I need to get a negative 8. So I'm going to make it a negative 10. So let's rewrite this. 2 still has to stay on the outside, so I'm going to do x minus 10, x plus 2. Okay, so this is where it gets tricky. Now I have a number on the outside, and it's not something I could divide them all by. So the first thing I do is I take the 2 in front and I multiply it to the thing at the end, and I'm going to rewrite it. So I'm going to rewrite it as x squared minus 15x plus 36. All right, so then now I'm going to do my little chart from here. So you take this out, multiply it to that, add it to the end. So 36, I need to find things that multiply out. We already did a 36 table, so 2, 18, 3, 12, 4, 9, 6, 6. So to get 15, I need that 3 and 12, and I think they're both going to be negative. So I'm going to do x minus 3, x minus 12. But we're not done yet. Remember, there is that 2, so now we have to divide by 2 to bring this back in. So notice the 3 doesn't divide by 2, so if it doesn't divide, slide it into the front. So it becomes 2x minus 3, x minus 12, so this does divide, and it becomes x minus 6. So that's how I factor that. That method is a little bit confusing, but I'll do another one because this is kind of new to me as well. So let's do number 15. Again, I can't divide everything by 3, so I'm going to take the 3 and multiply it to the end. So it becomes h squared minus 19h. 3 times negative 40 would make it negative 120. Then I have to think all the things that go into 120. I know 12 and 10 would be a good one. Let me find out others. 120 divided by 5, so 5 and 24, which that actually kind of works out, so I'm going to stop there. Because if I have a negative 24 plus a positive 5, I would get that negative 19. So I'm going to do h, make sure to do this right, plus 5, h minus 24. Now remember, you got to divide by 3. 5 doesn't divide by 3, so you bring it to the front and keep this the same. 24 does divide by 3, so it becomes h minus 8. Let's do number 19. Let's skip down. So again, I don't have a GCF to reduce this, so I'm going to take 9 and multiply it to the 4. So it becomes x squared minus 12x plus 36. Remember, 36 has so many things that multiply to it. I have 6 and 6, 4 and 9. What else multiplies out to 36? Oh, well, I kind of have it, right? If I make this negative times negative, that'd be positive. And then if I add them, I could divide each by 9. Now, okay, let's reduce this fraction. So it's x 2/3, right? So again, I don't want that fraction, so bring the bottom to the front. So then technically I could rewrite it as 3x minus 2 squared. Then we could do the difference of squares, which remember is a squared minus b squared equals a plus b, a minus b. And I remember loving this back when I was in algebra. So square root of 4 is 2, so x minus 2, x plus 2. For this one, you just kind of take the square root, so it's 3x, and then minus 5y squared, 3x plus 5y squared. This one, we're going to divide a 2 out, which leaves us with 36r to the 6 minus s squared, which now that's like a perfect square. So 6r3 minus s, 6r3 plus s.